Awesome work, you've just completed one of the most important topics in C++, arrays. You've learned what arrays are, how they work in memory, how to create them, loop through them, and use them in real code. And that final challenge. If you solved it, that means you're thinking like a programmer. But we're not done yet. Next up, we'll take arrays to the next level with multidimensional arrays. 2D arrays, nested loops, matrix-style thinking, and way more coding practice. So hit subscribe, like the video if it helped, and I'll see you in the next one. Keep learning, and keep coding. Before we start coding, let's understand what a multidimensional array really is. At its core, a multidimensional array is just an array of arrays. The most common example is a 2D array, which you can think of like a table with rows and columns. For example, imagine you're designing a spreadsheet or a grid in a game. That's a perfect use case for a 2D array. Let's say you have 3 rows and 4 columns. Your array will hold 3 times 4 is equal to 12 values. But here's the interesting part, under the hood, C++ stores these values in row major order, which means it lays them out row by row in a single block of memory. This is important, especially when performance matters, because accessing elements by row is often faster due to how memory is cached. So, conceptually we see a grid, but in memory, it's all a long sequence, carefully organized row by row. Now that we understand the concept behind multidimensional arrays, let's see how to declare them in code. In C++, a two-dimensional array is declared using 2 pairs of square brackets. The first one represents the number of rows, and the second one is for the columns. For example, this line of code, int matrix, 3, 4, creates a 2D array with 3 rows and 4 columns, giving us space for 12 integers in total. Each cell in the array can store 1 integer, just like a table with labeled rows and columns. Now remember, the index always starts from 0. So the valid row indices here are 0, 1, and 2, and the column indices are 0, 1, 2, and 3. You don't have to initialize the array right away. C++ will fill the array with default garbage values unless you assign values manually or use an initializer. Also, note that the size of each dimension must be known at compile time. This means you need to specify the dimensions explicitly unless you're using modern dynamic structures like vectors. So to summarize, a declaration like int matrix, 3, 4, gives you a simple, fixed-size 2D array. A structured way to organize data in rows and columns, perfect for tables, maps, and more. Now that we know how to declare a 2D array, let's learn how to initialize it with actual values. In C++, you can initialize a two-dimensional array at the moment of declaration using nested braces. Each pair of braces represents a row, and inside each row, we list the values for each column. Let's take this example, int matrix, 2, 3, equals 1, 2, 3, 4, 5, 6. Here, we're declaring a matrix with 2 rows and 3 columns, and we're assigning values to every cell. The first inner brace, 1, 2, 3, becomes row 0, and 4, 5, 6 becomes row 1. So when you access matrix, 1, 2, you'll get the value 6. Because it's in the second row, index 1, and third column, index 2. You can also write the entire array in a single line, like this, int matrix, 2, 3, equals, 1, 2, 3, 4, 5, 6, C++ will still fill it row by row automatically. But using nested braces makes your code more readable, especially when working with large tables. Keep in mind, if you provide fewer values than needed, the rest will be filled with zeros. But if you provide more values than the array can hold, the compiler will give an error. So, always match your initial values to the array size. To summarize, initializing a 2D array gives it real data from the start. And helps you write cleaner, safer, and more predictable code. Now let's see how to access individual elements in a 2D array. Each value in the array is located by using 2 indices. one for the row, and one for the column. For example, in this array, int matrix 2, 3 equals 1, 2, 3, 4, 5, 6. If we write matrix 0, 0, we're asking for the value in row 0, column 0, and that gives us 1. If we write matrix 1, 2, we move to the second row, third column, and that returns 6. Remember, indexing starts at 0. So matrix 1, 2, is not the first row and second column, it's actually the second row and third column. You can also assign values directly to a specific location. For example, matrix 0, 1, equals 99, this updates the second value in the first row, replacing 2 with 99. Accessing and updating values like this is essential for all kinds of real-world applications, whether you're building a grid for a game, managing user input in tables, or performing matrix operations. So always keep in mind, accessing a value in a 2D array is just like finding a cell in a table, you need the row index, and the column index. Accessing elements one by one is fine. But what if you want to process every element in a 2D array? That's where loops come in. To loop through a 2D array, we use two nested loops, the outer loop goes through the rows. And the inner loop goes through the columns of each row. Let's take this matrix as an example, int matrix 2, 3, equals 1, 2, 3, 4, 5, 6. If we want to print every value in this matrix, we can use for int I equals 0, I less than 2, I plus plus. For int j equals 0, j less than 3, j plus plus. Cout matrix I, j. Cout end L. Here's how it works, I goes from 0 to 1 representing each row. J goes from 0 to 2 representing each column in that row. So on the first pass, it prints 1, 2, 3. Then moves to the next row and prints 4, 5, 6. With nested loops, you can print all values. Search for something specific. Apply operations like sum, average, or transformation. And remember, the loop limits must match your array size. Otherwise, you'll access out-of-bound memory and cause bugs. So to summarize, looping through a 2D array is all about using 2 for loops. And it gives you the power to work with the full dataset efficiently. Alright, let's bring everything together with a live coding example. We'll build a simple C++ program that declares a 2D array, fills it with values using a loop, then prints the values in a nice grid format. Here's how it starts, include iostream. Using namespace std, int main. Int table, 3, 3, we've declared a 3 by 3 array named table. Now let's use nested for loops to fill it with values. Int value equals 1, 4, int I equals 0, I less than 3, I plus plus. 4, int j equals 0, j less than 3, j plus plus. Table, I, j, equals value, value plus plus. Here, we're starting with value equals 1, and we assign it to each cell. Each time we assign a value, we increment it, so the array gets filled from 1 to 9. Now let's print the entire array, 4, int I equals 0, I less than 3, I plus plus. 4, int j equals 0, j less than 3, j plus plus. Cout table, I, j. Cout gendel. This will output 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. You've now seen how to use loops to populate a 2D array, and display its values in a readable format, like a grid or matrix. This pattern is incredibly useful in games, simulations, tables, and algorithms that rely on grid-based data. Time for a quick quiz. Let's test your understanding of everything we've covered about 2D arrays. I'll show you a short code snippet, and you try to guess the output. Here's the code, int matrix, 2, 2, equals 10, 20, 30, 40, cout matrix, 1, 0, end L, think about it. We're printing the value in row 1, column 0. What do you think the output will be? Take a second. The correct answer is 30. Because matrix 1, 0 means second row, index 1. First column, index 0. And the value there is 30. Here's another one, int grid 3, 3 equals 1, 2, 3, 4, 5, 6, 7, 8, 9. See out grid 2, 2, what's the output now? If you said 9, you're absolutely right. This quiz shows just how important it is to understand zero-based indexing and how rows and columns are structured. Keep practicing with small arrays, and soon this will become second nature. Let's wrap things up with a final challenge, no multiple choice this time. Just you, your brain, and the logic of 2D arrays. Here's the task: you have a 3 by 2 matrix declared like this, int numbers, 3, 2, equals 2, 4, 6, 8, 10, 12, now imagine this loop, 4, int I equals 0, I less than 3, I plus plus. 4, int j equals 0, j less than 2, j plus plus. See out numbers, I, j. What do you think the full output will be? You can pause here and try to write it down or visualize it mentally. Ready? The key is to understand the structure: first row, 2, 4, second row, 6, 8, third row, 10, 12. So the nested loop will print each element in order, row by row. The full output will be 2, 4, 6, 8, 10, 12. This is a simple but powerful example of how nested loops let you access all elements in a 2D array, from top left to bottom right. Your mission now: try building your own 2D arrays, play with different sizes, and see how the indexing works. That's how you'll master it, not by memorizing, but by practicing. Awesome job, you've just tackled one of the most visual and powerful features of C++, multidimensional arrays. Now you understand how to declare and initialize 2D arrays. Access and modify their elements using row and column indexes. Loop through them using nested for loops. And even visualize them like a grid in memory. This is a huge step forward in your C++ journey, especially when dealing with structured data like tables, maps, matrices, or even games like tic-tac-toe. But we're not stopping here. In the next video, we'll go even further. You'll discover a more flexible and dynamic way to store collections of data. That's right, we're talking about vectors in C++. If arrays are like rigid boxes, vectors are like smart containers. They grow, shrink, and adapt to your program's needs. So stay curious, keep practicing, and I'll see you in the next lesson.